Good morning, my YouTube viewers, or I should say good afternoon. It's Crystal here, and what I wanted to do is I wanted to do another code review for you. But what I will do is I will leave a link to the Jupyter notebook in the description box down below so you can see all the code. And what this is a community competition with Kaggle, and it was relating to Tic Tac Toe to determine the result, who was going to win the game. And so what they do is they give you a data frame, a data set, and in the data set it's going to be a series of X's or O's, and then with these series of X's or O's it determines whether a person wins or loses. And so basically that's what we did in this program, in this Jupyter notebook. So the competition was concluded, but I went ahead and did a late submission. And one of the good things about doing a competition after it has closed is the fact that you can submit your work as many times as you like, because you're not going to get graded on it. I mean, they'll tell you what your score is, and you can look on the leaderboard to find out where you were on the leaderboard, but it's not going to put your work on the leaderboard because you entered the competition after it had closed. So I got 98.9% accuracy whenever I did my first submission, but since I submitted it after the competition was closed, so I don't get any credit for that. But I wanted to go ahead and do a code review for you anyway, just so you can see what I did. So we've already talked about the fact that this is a tic-tac-toe game, and you have depending upon where the X's and the O's are, will depend upon whether a person wins or loses. So I actually forgot to put the problem statement in there, but the problem statement is to determine who wins or loses in the tic-tac-toe game. So the first thing that we're going to do after we create our Jupyter notebook and we do the problem statement, which I forgot to do, is we're going to import the libraries into the program. And so basically, in this particular occasion, I did it the way it's supposed to be done, whereas I put all of the libraries at the beginning of the program, when that's the way you're supposed to do it. So we imported NumPy as NP to create NumPy arrays and perform numerical computations. We imported pandas as PD to create the data frames in the series and also process the data. We import OS, which goes into the operating system and retrieves the files. We import sklearn.utils. Well, we just import sklearn, and that provides your machine learning functionality. And then we imported a lot of the functions from sklearn library. We import tensorflow as TF. That provides your deep learning functionality. From TensorFlow, we import keras. That helps you make your model. We wanted to see what version of TensorFlow we're on, and we're on version 2-12. It's always important to know what version of TensorFlow you're on, because this library goes through so many changes. And so you want to make sure that you're not working with deprecated code. We're going to import matplotlib.pyplot.sblt, and that helps you visualize your data. And we're going to import Seaborn as SNS, which also helps you visualize your data statistically. So you can see here we're on version 2.12, and so you need to keep track of what version of TensorFlow that you are on, and the reason why is because TensorFlow goes through so many changes that it goes through so many changes that you're going to encounter a lot of deprecated code and encounter a lot of changes to the code. So in order to make sure that you're working with the right code, you have to know what version of TensorFlow you're using. So what we wanted to do is we wanted to set the seed. And so when you set the seed, what that does is that makes sure that whenever you run a program, it always comes up with the same solution or the same answer. Then we're going to use the OS library to retrieve files from the operating system. And we had 3 files. You had a Tic Tac Toe data set, you had a train, and you had a test. So now what we're going to do is we're going to use pandas to read the retrieved files. So we're going to read them as this train, test, and TTTDS. So you can see the train file gives you lots of X's and O's. At the very end, it gives you an ID and it gives you a class. Now, the ID you're not going to need, and the reason why is because every row in the data frame is already indexed by pandas. And then so you've got your class that tells you whether they win or lose. Test is the same format as train, with the exception that it doesn't have the class. And the reason why it doesn't have the class is because that's what we're going to be predicting on. So TTTDS, that's 958. So I think the TTTDS is like the train and the, I think it is the train and the test, because here you've got 662 and here you've got 296. So you've got 958, I think. And so what does it say here? 958. So that's just a combination of the train and the test. And it also tells you what the class is. So you know what the class is because it tells you what the class is. So that's interesting. So, but I didn't even look at the TTTDS. I just looked at the train and the test. We're going to check for null values in the train. Unfortunately, there's not any null values, so we don't have to impute anything. And then we're going to check for null values in the test, and there's not any null values, so we don't have to impute anything. We're going to drop the ID from the data frames because Pandas automatically indexes the rows. So train ID equals train.pop ID, test ID equals test.pop ID. So we will be using test ID at the end of the program. We're going to analyze the label. We're going to use Seaborn to do that, to create a histogram. And so you can see here that we've got an unbalanced, a class imbalance. You see we've got more zeros than we do ones. So, and then what we're going to do is we're going to establish our dependent and our independent variables. And I made a mistake there. I said dependent and dependent. It should be dependent and independent variables. And so y equals train.pop class, that's your target. X equals train, and x test equals test. And now what we have to do is we have to define our class weights, and we have to do that because we have an imbalanced data set. Now we're going to pre-process the data set. So we create a function called def preprocess data, takes data as input, data equals data.replace, replace x with 1, replace o with -1, replace b with o, and then you return the data. So x equals pre-processed data x, and x test equals pre-processed data x test. And now we're going to use sklearn's train test split to split the data set up into training and validating sets, so you can see what the training and the validating sets look like. Now we're going to use TensorFlow and keras TensorFlow to define our neural network. And you can see here that we've created a sequential model. And then the first layer is we flatten the data. Then we have a dense layer using the ReLU activation function of 64 neurons, and another dense layer using the ReLU activation function with another 64 neurons. And on the flattened layer, the number of neurons is in the beginning is the number of features. And so I'm not sure how many features we have. We've got 9 features. So the number of neurons is at the beginning is going to be 9. And then and we have another dense layer of 64 neurons with activation function is ReLU. And then now we have our output layer is 1 because it has only one output, and the activation function is sigmoid. And then after we do that, we compile the model, and so the optimizer is atom, the loss is binary cross entropy, and the metrics is accuracy. And so you've got a summary of the model here. Now what we're going to do is we're going to train the model, but before we train the model, we set up my callbacks. So that sets the model up for early stopping, and patience equals 25. So history equals model.fit, xtrain, ytrain, epochs equals 200, batch size equals 32, validation data equals xval, yval, my callbacks equals my callbacks, class weight equals class weights, and then val loss val ac equals model evaluate xval, yval. So we train the data, and then we go through all these epochs until it stops early. It stopped at 122 out of 200, gave you a 97% accuracy. And then we plot it on a graph, and you can see the loss in the accuracy of the training set and the validation set. And so we're going to predict on the validation set, so you can see all the ones and zeros in the validation set. Check the accuracy is a 97%, which is pretty good. Set up our confusion matrix. So our confusion matrix, we only had 2 incorrect, 2 zeros when they should have been 1s. And then we check we create a classification report, and that gives us a 97% accuracy. And now what we're going to do is that we're going to predict on the test set. So these are all our zeros and 1s. And then what we're going to do is we're going to create a histogram of the predictions. And so you can see that you have that class imbalance of more zeros than 1s. And then we're going to prepare our submission. Submission equals pd.dataframe. And then we're going to put it into the data frame into a dictionary. So ID is test ID and class is pred. Submission.toCSV, submission.csv, index equals false, submission equals pd.readCSV, submission.csv, and then this is your submission. And then so when we submit our work to Kaggle, we got a 98.9%, which isn't too bad. That was a pretty good accuracy. I mean, I've worked on some problems where they had a very poor accuracy, but accuracy here was pretty good. And so I was looking at the sample code for this problem, and on the sample code for this problem, somebody actually used k-mean squared to predict on it. So rather than making predictions in the normal way, they put everything into a cluster. And so that was very interesting. I didn't do that. I looked at the code, but I didn't do that. So I'm going to go ahead and conclude this video because we've completed the code review. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, then please tap onto the bell button next to the subscribe button. And thank you very much for watching my video. Thank you to my subscribers for supporting my channel.